Hi students. Today we are going to do short 2 from alcohols, phenols and ethers. Prasanna here. Welcome to my platform ChemSmart. So let's see what are the PYQs in this session. Number 1. Carry out the following conversions. Carry out the following conversions. Each one is 1 mark and they are asked in 2020 as you can see. Phenol to salicylaldehyde. You know, phenol to salicylaldehyde is nothing but Raymer-Thieme reaction, isn't it? So you know how to present it. We have done it in the last class also, last session also. That is, if you have phenol, what you can do? Make it react with chloroform and aqueous NaOH. Then you will get substituted benzyl chloride intermediate, which will react further with NaOH. Here you have to heat it also. Further with NaOH, you will get ONaCHO. We have discussed the same thing in the last session also. And then that on further acidification, you will get OHCHO. That is 2-hydroxybenzaldehyde or 2-hydroxybenzene carbaldehyde. That is salicylaldehyde. So this is Raymer-Thieme reaction. Practice very well. So phenol to salicylaldehyde completed. That is, you have to write for 1 mark. Now, this question is a bit tricky. I would say very tricky, where many students may lose mark. Tertiary butyl chloride to tertiary butyl ethyl ether. You know, to prepare an ether, we normally follow Williamson synthesis from alkyl halide and alkoxide given, right? Which is SN2 mechanism. I have told you in the previous session. And if the alkyl halide is tertiary, SN2 mechanism becomes difficult due to increased steric hindrance, right? So here tertiary butyl chloride is the starting material. Okay? So that is a tertiary alkyl halide, which if you proceed with, you will not get ether because elimination will be preferred over substitution and you will be getting alkene. You will not get ether. So you have to take care. You have to use your brain, apply. So here you need tertiary butyl ethyl ether. Tertiary butyl and ethyl, they are the 2 alkyl groups required on both the sides of ether, either side of ether linkage. So, but tertiary butyl part is alkyl halide. We cannot proceed with tertiary alkyl halide because what you need is ether, not alkene. So what you have to do here is, this tertiary butyl chloride, you have to convert into tertiary butoxide. If the alkoxide is tertiary, no problem. The alkyl halide cannot be tertiary. Understand? So this one, you can convert into tertiary alkoxide. And the alkyl halide, what you are going to use should be primary. So this one, you will convert into a tertiary alkoxide and you will maintain the alkyl halide primary. Then you will get the ether. So let's see how to deal with it. Here what we have is tertiary butyl chloride. So let us convert it to tertiary alkoxide. Let's see how to do it. What we have is CS3 tries CCl. This is tertiary butyl chloride, right? Make it react with aqueous NaOH or it can be aqueous KOH also, aqueous alkali. Then it will undergo substitution. That is, you know, NaCl will get removed, OH will take that place. So you'll be getting CS3 thrice COH. Right. You got tertiary butyl alcohol, 2-methyl-propan-2-ol. Make it react with metallic sodium. Our aim is to convert it into the alkoxide. So I'll be getting CS3 thrice C. Now I'll get ONA. Right? CS3 thrice C, ONA. I got sodium alkoxide of the tertiary alcohol. Now you are safe because the alkyl halide status has been changed. Okay? Alkyl halide, tertiary alkyl halide, we have changed it into tertiary alkoxide. Now, simple. Now make it react with primary alkyl halide. Here, I want ethyl group to be introduced, so I can use ethyl chloride, bromide, or iodide. That's your wish. Then what will happen? It will undergo substitution. NaCl will get removed here, and you will be getting CS3 thrice C, then OC2H5. Now you got your ether, right? You got tertiary butyl ethyl ether. So practice this question very well. I have already told you in the previous session also, this application is very common in recent years, most of the papers. Make sure to practice. Otherwise, you will be in trouble. Okay? Now, next one is mechanism of formation of ethanol from ethene as well as ethene from ethanol. This is ethanol from ethene. That is ethene to ethanol. This is ethene from ethanol, means ethanol to ethene. Both these mechanisms, actually there are three mechanisms which are very important from this chapter. Alkene to alcohol. Most commonly it is ethene to ethanol. First one. Ethanol to ethene. Second one. And third one is ethanol to ether, alcohol to ether. These three mechanisms you have to master, the three-step mechanisms. Sometimes it will be for 3 marks, sometimes it is for 2 marks. Anyway, you cannot escape from the mechanism. You have to write and practice the mechanism. Almost 100% sure you will get one mechanism in your paper. It is very difficult to see a board paper without a mechanism. Okay? So, I'm talking from my experience. So, you please make sure to practice the mechanisms very well. Okay? Great. So, these things, practice from the textbook. I don't think we have to discuss that here in this session. Next one is some conversions. Predict the reagent for carrying out the following conversions. Basically, you have to write it as a conversion, indicating the reagent used. First one, phenol to benzoquinone. You know, phenol on oxidation, you will get benzoquinone. Phenol, when you oxidize using acidified sodium dichromate, Na2Cr2O7, in the presence of H2SO4, that is acidified dichromate. Sometimes they will write Na2Cr2O7/H+. That means in the presence of acid. It is getting repeated in the same session. Okay. Then you will get benzoquinone. What is benzoquinone? It is a conjugated diketone. You know, this is one ketonic group. This is one ketonic group. So it's a diketone. Why we say it is conjugated? Conjugated means alternate single and double bonds. So double, single, double, single, double, single, double, single. So it is getting alternate single and double bonds. That's called conjugated diketone here because it's a diketone. Clear? And conjugated. Now practice this well. Next one, anisole to para-bromoanisole. Anisole is methoxybenzene. That is getting brominated. Then you will get, because the OCS3 group is ortho-para directing, you will get two products, ortho product and para product, and we can separate them. Okay? Para is the major product. You already know that. So how to do this? Here, anisole is methoxybenzene. If you treat it with bromine in ethanoic acid, so this is the reagent used here, bromine in ethanoic acid. You will get ortho product plus, so this is the minor one and this is the major one. So the reagent used here is bromine in ethanoic acid. Hope it is clear. Very simple. We have taken this because these are latest board questions. Okay. Now, next one, phenol to 2,4,6-tribromophenol. Phenol on bromination. You know, there are two types of brominations with, bromine in carbon disulfide. That is a non-polar solvent at 0 degrees centigrade, or bromine in aqueous medium. Then all the three positions will get, it is a polar solvent, water. So all the three positions will get simultaneously attacked. So we are going to see what the reaction is. Phenol to 2,4,6-tribromophenol. All the three positions are simultaneously substituted. 2,4,6. So we have to use aqueous bromine. I have just balanced it because 3 bromines you need to get substituted and 3 outgoing hydrogens. One from here, one from here, one from here. 3 hydrogens will be going out. To combine with them, 3 extra bromines you require. So 3 for attaching and 3 for combining with the hydrogen atoms, 3 hydrogen atoms. So totally 6. Then you will be getting what? 2, 4, 6 tribromophenol. 2,4,6-tribromophenol. So the reagent used is aqueous bromine. Plus 3 HBr will be the byproduct. So the reagent used here is what? Aqueous bromine or bromine water. Now let's go through them quickly once more. For phenol to benzoquinone, what is the reagent used? Na2Cr2O7 acidified. For anisole to parabromoanisole, what is the reagent used? Bromine in ethanoic acid. And phenol to 2,4,6-tribromophenol, what is the reagent used? Aqueous bromine. Clear? Right. Now, next one is what happens when? What happens when means in such questions, you have to be very careful in presentation. Sometimes students write only the equation. I feel that's not enough. Give a brief explanation. Okay, like that is highlighting what is the real chemical process happening in that reaction. Clear? It is always better. Salicylic acid is treated with acetic anhydride in acidic medium. I have told you, see, this is 2019. We have seen the same thing in one format in 2023, in another format in 2022. 2021, there was no board examination. 2020 also, this was repeated. Now I have just taken it, quoted it from 2019 paper to show you the importance of that particular reaction. So what students write here is salicylic acid is treated with acetic anhydride in acidic medium. They'll write aspirin is formed. That is not enough. Okay, aspirin is formed. So you will say aspirin is formed. You will give the equation completely. Then you will write it forms aspirin by acetylation of salicylic acid. Understand? Salicylic acid is acetylated. That's a key term. Acetylated to get aspirin. That is esterification actually. What is happening here? Okay, the OH group of the salicylic acid, it is undergoing esterification with acetic anhydride. So it is getting acetylated. Clear? Make sure to use these key points, keywords. Then phenol is oxidized with Na2Cr2O7 bar H+. We just completed it. Phenol gets oxidized. That is the keyword. Oxidized to form the conjugated diketone, benzoquinone. Understand? Then give the equation. That is a presentation. Then anisole is treated with methyl chloride and anhydrous AlCl3. Anisole, when treated with the methyl chloride in anhydrous AlCl3, it is actually Friedel-Crafts alkylation of anisole. So that we haven't discussed yet. So I'm just going to do that area for you. So it is anisole. Anisole is methoxybenzene. It is undergoing Friedel-Crafts reaction, CS3Cl, in the presence of anhydrous AlCl3. So make sure to write that it is Friedel-Crafts reaction, either on the arrow or in the bracket. Okay, that is called presentation. Okay, Friedel-Crafts reaction. Now, if it is undergoing Friedel-Crafts reaction, what will you get? OCS3, then one product will be ortho and the other product will be para. This is minor. You have to indicate that in the bracket, minor and major. And I think in 1 year, they asked the IUPAC names of these compounds also. This is 1. So 1, 2. 1 methoxy, 2 methylbenzene. This is 1-methoxy 4-methyl benzene. Okay. In your textbook, it is written orthomethoxy or 2-methoxy toluene and 4-methoxy toluene. But you have to use the typical IUPAC name. So better go for 1-methoxy 2-methyl benzene or 1-methoxy 4-methyl benzene. Clear? Now you have to write the IUPAC name of this compound. This is also a bit tricky because ethyl group is given here. Ethyl group is given means in such a case you will have to expand it. Understand? Many students fail to do it and they get a wrong name and 0 mark. Okay. So let us see how to do this. You know, this is C2H5. That you have to expand. I am doing it here itself. CS2, CS3. That is C2H5 expansion. Whenever ethyl group is there in the question, make it expanded. Get it expanded. Sometimes it will contribute to elongating the chain, sometimes not. So let's see now which is the longest chain. If you just neglected it, 1, 2, 3, 4. 1, 2, 3, 4. But this way, 1, 2, 3, 4, 5. This is the longest chain now. That means the longest chain changed, right? When you expanded it. Now, should we number the chain from left to right or right left? 1, 2, 3, 4. Fourth carbon is holding OH. 1, 2, 3, 4. 1, 2, 3, 4, 5. Fourth carbon is holding OH. Going from right to left, 1, 2, 3, 4, 5. Second carbon is holding OH. You know, lowest locant position you have to see. So, 1, 2, 3. That is, the OH holding carbon should get the lower number. So, what is the name now? The name will be 3,3-dimethyl pentan 2-ol. So, it is 3,3-dimethyl pentan 2-ol. Be very careful when you are given ethyl group as a branch. Always expand it. Sometimes it may not contribute to a longer chain, but sometimes it will. So take care. Okay. Now the next question. Write the structures of the main products in the following reactions. Here, what you have to do? In the first case, we have done a similar question in the previous session. I feel so. This is an ester linkage, whereas this is a ketonic group. We are using sodium borohydride. Sodium borohydride is a reducing agent. I have told you before also, it is not reducing ester linkage, but preferentially reducing the ketonic part. So what happens is the ketonic part, that is this part will change into secondary alcoholic group and this will remain as such. This is from the textbook. Same question is there in your textbook. Clear? Now, so this is the answer. This one, you know, here it is C and it will be CH when you satisfy the valency, tetravalency of carbon. So you can see this is this side, it is not symmetrical alkene, it is unsymmetrical alkene because this carbon has 2 hydrogens, this carbon has only 1. Now you are adding water. Water we are writing H plus OH minus. You are adding water into an unsymmetrical alkene in the presence of acid, where you have to follow Markovnikov rule, right? So what is Markovnikov rule? The positive part of the addendum will go to carbon holding greater number of hydrogen atoms. So that is CS2, greater number of hydrogen atoms. Negative part of the addendum goes to the carbon holding lesser number of hydrogen atoms. Here it is only 1. So what will be the product formed? The product formed will be here. This is benzene ring. Now this will become OH. So here it will be CH, OH. See? OH comes here. So CHOH. Then this becomes single bond. And CS2 and H will become CS3. So that is the answer. Apply properly. Okay? Adding water to unsymmetrical alkene follow Markovnikov's rule. Now, the next one, it's an ether. Ether is going to get cleaved using hydrogen halide. And what you have to do here. Look, either this bond or this bond will get cleaved during the attack of an ether by hydrogen halide. But which bond will get cleaved preferentially? This bond, this C, because it is benzene ring, this C2O bond has a partial double bond character. It will not get cleaved. So only here it will get cleaved, okay? Between alkyl group and O. Aryl group and O will not be cleaved, partial double bond character. So this is plus and minus. So this is minus, O is minus, and here it is plus. So H plus will come here, okay? So it will become phenol, and I minus will come here with C2H5 plus. So the product will be what? Phenol plus C2H5I. Cleavage of ethers using hydrogen halide. That concept is also very commonly asked in recent board papers. Make sure to practice. Right? Okay. So, we have completed this session. I hope all these questions are okay for you. You got the ideas properly and the applications properly. See you inside for the next session. And make sure to like, share, and subscribe to my channel, as I always tell you. And also make sure to watch all the other videos which I have uploaded in my channel. Okay? It will help you a lot.